very simple example. Okay. So first, this is given the data. I'm calling this as the X part and this as the corresponding Y part. Okay, X1, I'm calling this as Y1. This is X2, this is Y2, this is X3, this is Y3. So this we can call as the output and this we can call as the input. So seeing this data itself, right, something clicks in your mind. Okay, because right, you are all literate persons, so you all know multiplication, addition, so something clicks in your mind. But if I shown the same data to an illiterate person, no, nothing will go. That person will just say this, right, this set. But as far as you are concerned, you know what is the relationship between x1 and y1. And after giving this data, if I ask you what is the answer, can you say what is the corresponding y? At once you will say, because from this you have understood that y is equals to, right? It is like, right, 3 into x, right? From using this information, you will be able to find what is test data. Okay? So if you have understood this, right, we have, right, we have crossed the first phase. I would say that we have crossed the first phase. That is, you have understood what is machine learning. This is what exactly is happening. Okay, given the data, you are now the learned model, and the learned model, right? Is there any disturbances coming?
Yeah, ma'am. But I think not from your end. Yeah, it's
Okay.
fine. Yeah, fine. Yeah.
Okay. So this is the data and you are the learned model. You extracted the informations from data and you will going to use that for future predictions, right? This is exactly what is, right? Extraction of information from the data. Okay, right? Now from this example, we are going to move to the next one. Okay. Here, this is x1, this is y1. This is x2, this is y2. This is x3, this is y3, right? But here x1 is a real number or a scalar. But here it is not. It is a vector of length greater than 1, right? These are all vectors of length greater than 1. Now, I will show you the data. And now if I ask you what is the answer for this one, right? Things have become little bit complicated. It is not as easy as the first one. You may write, oh, what is going on? Is there a relationship? You will right, will search for a pen and paper, right? A paper to write out what is going on, right? This are the some right consequences that may happen if I show this data and ask you to find the relationship. That is, this is not as easy as the first example, although there are three datas are there, but the data, right, structure of the data has become more complicated, right? So now you can imagine, right? If we have a database of millions and millions of data, right? And each data, this is called the input. This each, right, xi, or the input is of high dimension or a vector of right, high length, right? So this is length 3. We have a very high length vectors, right? How we can, as humans, how we will be able to extract information? It is it is nearly impossible. Importance of machine learning algorithms, right? If you have understood these two examples, I say that we have, right, laid the foundation of, right, machine learning domain. This is what is, right, we are going to see how we can efficiently extract the information from a given data so that we could use that for future predictions just like this, right? This we, if I ask you what is x, given x, what is the corresponding y, right? We have to extract information from this and you can use this for this one, right? This is what is all about, right? Now, this is one set of data where you are given X and you're given Y. Now we will say about another set of data, right? Oh, Y part is there, only X part. Okay. This is X1, this is X2, this is X3, like that. It's okay. 1, 2, 3, 4, 5, 6. This is X6. And if I ask you to divide this into two different groups, right? Using some property of these numbers, maybe we'll put all the even numbers or odd numbers, some property which you think that is the most appropriate as per your decision, as per your knowledge, you may able to divide this into two different groups. You may able to do because you have a past experience, right? Using that experience, you would be able to divide the data into two different groups. Now I'm coming to this data, right? This is X1, this is X2, this is X3. Now, this is a vector of length, not one, but two. Two components are there. Now, if I ask you to divide it into two different groups, things will become difficult. Will I do it right? How will I divide this into two groups, right? What are the right? What are the properties that should I use to divide that into two groups? Right? These are the things that would come to your mind. So things are not so easy as the first example. So that so you can imagine, right? As I said in the first example, if you have, right, a very huge database which has lots and lots of data, and if we want to divide that into two very different groups, right, it is impossible as humans. It is we are cannot do that. That is why we need automated tools, right? So okay. So now we have huge data explosions, right? Everywhere we have data, and we have very sophisticated repositories to collect, store data. So, and this data is very rich in knowledge. So, what is lacking is, right, efficient tools. That they are all rich in knowledge, right? Just as right, we have derived information from this one. Can be right? There may be some underlying patterns in that data.
Ma'am, your voice is going low, ma'am.
It's okay. Now is it clear? Okay.
Yes, ma'am.
It's
Yes,
okay.
ma'am. It's not.
It's okay. So please let me know any problem, right? Okay. Okay. Right. So right. So we have lots and lots of data, right? So what is lacking is right. We need sophisticated right machineries to collect. We have sophisticated machineries to collect and store data, and what is lacking is right efficient tools to extract information from the data. Different types of data are there: image data, video data, sensor data, IoT data, lots of data. Is now this voice audible?
Yes, ma'am. Yes, ma'am. It's perfect. No issues.
Okay, right. Right. So with these few examples, right, we will start with what is machine learning. So this is a formal definition given by Tom Mitchell, right? He's working in Carnegie Mellon University. He's a professor. So as per him, he has given this formal definition. But right now, right, if you, I'll say that if you have right understood our previous examples, I would say that you have understood what is going on in machine learning, right? Now, why we need, right? Why we have to extract information from the data? What is the use of this, right? Where we can apply it, right? Lot of areas, right? Now you that word AI you are hearing each and every day, right? Now let us look at a very few very examples, right? For example, in the medical diagnosis, right? We have the corona patients data. Okay, right? Just as like this data, right? Like this data, you have corona patients data, right? This X part will be the symptoms. symptoms collected from each patient. So we may collect some group of, we'll collect data from a group of people. That group consists of corona patients, right, as well as normal subjects. And from each persons, we will collect some, right, some symptoms, right? Maybe blood pressure, body temperature, like that, as per the right advice of a right domain expert. We will collect symptoms from the data from each subject, and that will form the expert. Okay, maybe whatever that person has told us to collect, we will collect all those measurements from each subject. That will form the expert. Maybe this is body temperature, blood pressure, sugar level. That is we collect, and this part will indicate whether that has person has corona or not. Maybe we put y is equal to 1 if that person has corona, y is equals to 0 if that person doesn't have corona, right? Then now exactly as we have extracted information from here, we will try to find the relationship between x and y. And why we need that? Then given a person with only the symptoms, okay, only the symptoms, we would be able to find the corresponding y, that is either y is 1 or 0, using the given data. Okay, so this is right. So this is what is happening. So that is what is in the medical diagnosis. Okay, medical field, right? Huge right data repositories are there, right? And then definitely they may have some underlying right characteristics, important characteristics. So whether we would be able to identify those characteristics, so that right we could use that for applications like this. Okay, right? And then the fraud detections, right? Credit card transactions, right? Can the system right trigger an alarm, right? When a fraud, and it detects a fraud transaction, right? Or else in spam filtering, right? To right given a set of emails, right? Whether we would be able to right divide that into spam emails and non-spam emails, just like what we have done. We or just like the examples we have seen before, right? Or else in the weather predictions, given the temperature conditions of a particular day, what can we predict the weather for a particular season? Can we predict the weather? Or is natural language understanding, right? If I speak English, right? Whether the model can understand that language and whether it can convert it into text, or whether it can convert it into another language, right? Or so and so, and we have seen, right? So these are some of the applications. Not only this, right? Even an image, it has to right detect the face, right? Or else all of you have seen AI cameras, right? A person who's coming, but he has hidden some weapon here, right? So at once it has to trigger an alarm. Something is hidden here, right? So using this, right? The right. So what techniques we could use to right to derive such to model such applications, or else all of you know, right? Chat GPT, what is going behind that Chat GPT, right? So in all these, we can see the machine learning applications, or else all of you have seen that self-driving car, right? Or else, right, we want to develop a robot that could, right, work in very dangerous terrains and mines. How is it possible? Okay, the robot that could take decisions by its own, right? Or else, right, for a space applications, whether we would be able to, right?
Excuse me, ma'am.
Yeah. Is it my?
Uh, yeah, participants. Is the slide is visible for you? For me, it's not an issue, but few participants are raising
It's
not
visible.
visible.
It's
Sir,
visible.
it's visible, sir. It's visible.
But it is three of them are messaging slide is not visible. Uh, yeah, I think continue, ma'am. I think it is
Sir,
visible, right?
they can disconnect. Yes, sir. They can
It
disconnect
is
and
visible, sir.
better.
Yeah, yeah. So those who are not visible, you just disconnect it and join again. I will accept it. Okay, that will be good. I think so. Just check it
Uh,
once.
Sir,
Okay.
even I faced the issue. It is a net issue, sir. Actually, not your fault. It's our fault due to net issues, sir.
Oh, okay. 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 Fine. You just check it once again and let me know. Okay. Okay. Please continue, ma'am. Yeah.
Okay, okay. So, right, so this is so this slide is visible, right? Intelligent robots, right?
Yes,
Okay,
ma'am.
okay. Now that is a brief introduction about the right machine learning. All is about extracting information from the data, and we have seen some applications. Now we'll go to the next next step, right? Now we are ready for the next step. We'll look it into some machine learning terminologies. First, I'll introduce something called overfitting and underfitting. Okay.
Ma'am, can you change the slide? Is it same in intelligent robots or?
No, no, now it is over. No, no.
Sir, it is changing, sir. For us. We are able to see that.
Can you read this?
Yes,
I
ma'am.
can see
The slide.
the slide of intelligent robots.
No, ma'am. The
Ma'am,
slide of
overfitting
overfitting
and
and
overfitting
underfitting.
and underfitting.
Okay, right. Yeah, maybe.
Ma'am, can you reshare it once again, ma'am? Once.
Uh,
I think the problem is at your end.
Yeah, I think so. When I reconnect it, I don't know. The meeting will disperse or not. Yeah, it's no issues. Continue, ma'am. I think is there anyone facing the issue with slides are not changing?
No, no.
It's okay. So the heading, I will say the heading. Okay, so if that is not visible, let me know. The heading now is overfitting and underfitting. Okay, right? So there are four figures are there. You can see that, right?
Yes,
Right?
ma'am.
Yes, ma'am.
Okay. Okay, four figures are there. And you have given, right, 1, 2, 3, 4, 5, 6, 7, 8, 10 data are given. Okay, this is how this data modeling happens. Okay, so we can say that it has one X part and this corresponding Y part. Okay, actually, this is the relationship. Actually, this is the function that generates this data. Okay, actually, after modeling, when we plot it, the function we are getting has so approximately equal
Ma'am,
to this.
ma'am, can you reshare the slides, ma'am, once again?
Okay.
Yeah. Sorry to interrupt you, ma'am. Yeah.
Yeah. Is it visible?
Not yet.
Is it visible to others?
No, ma'am.
No, ma'am.
Ma'am, no, ma'am. No, ma'am.
Ma'am, no, ma'am.
Is it now visible?
No.
No, ma'am.
Ma'am, can you share or otherwise you just send, can you send me the presentation slide, ma'am? I will share it. Is that okay for you, ma'am? Yeah, ma'am, it's visible, ma'am. Can you scroll down, ma'am, once? Hello, ma'am. Yeah, muted, ma'am. Yeah. Ma'am, you are muted.
Okay, so is it right?
Yes, ma'am. Can you change the slides, ma'am, once? Yeah, ma'am. It's fine. Fine, ma'am. Fine. Thank you.
So,
Thank you. Yeah.
it's okay. So, right. So it is overfitting and underfitting. Okay. So how this data is look like? You will be seeing only this 10 data in your hand. Okay. From that, you have to develop a model, and that model, right, in ideal case, or that model should look approximately equal to the true function, right? That is the objective of data modeling, right? So you will be seeing, you will be given 10 data, but as you can see that this is the true function. If this, we call this as the X part and this is the Y part, there is a small error, right? Because, the data we are getting has some noise, right? Because usually the real world data is noisy. There may some errors come, right? While collecting the data. It's so many, we never get very pure data. There will always be some noise in the data. So here also we are getting some noise data because for this X you are seeing this Y instead of this Y. The small error is there. So so you will be given like this data X1, Y1, 2, right? X 10, Y10. This one we will only seeing this one. At the end, you have to get the function like this. This is what developing a model means. And I have given this task to 4 different persons. And one first person comes up with this one, this red line, and says that, right, this is the, this is the one, the data looks like this, okay? Right, and this is the true function. And the second person says that, right, this is the true function, right? Right, this for the first persons, this is the true function. This is the true function for the second person, right? And for the third person, this is the true function. And the fourth person, it says that this is the model. Okay, so 4 models, 4 different persons, 4 models are there. Right, so you can see the red one is the one which has been developed by 4 different persons, and actually the blue one is the true function, right? So which is the best one? Is it this one, this one, this one, or this one? Which is the best one as per you? Is it the first red one, or second red one, third one, or fourth one? Which person has which person's model is approximately equal to the true function? 1, 2, 3, 4. Which is the one? Can you say? Is it the third one? Okay, third one. Okay, third one. So, okay, you said that third one, right? But as you can see that the third one, it is not exactly passing through the given X and Y. It is not exactly passing. But, right, as you can see that it is approximately equal to the true function. And here what is happening is, it is exactly passing through all the given xy points, but it has no similarity with the true function, right? For the given data, for the given x1, x2, and both the error caused by this one, this relation is 0 because it is exactly passing through the given points. But when we show to the new data, this will be a total failure, because when new data means which we have not used to develop the model, this will be a total failure, right? But although this one, if we take the training error means the error which we obtain using the data which we have used to develop the model. So the training error, it may not be 0 in this case, but still, right, when we show to the new data, right, the performance of this will be much better than the performance of this red one. Okay, so these are all the challenges, right? So if one model is performing well on the training data means the data which we have used to develop the model, doesn't guarantee that, that model is the one by which the data has been generated, right? As this example. So here we say that overfitting has happened. Okay, overfitting, right? Because it works fine only for the given data. Okay, so there will be a population. Population means the entire data set. From that entire data set, we are seeing only 10 data, right? Using that 10 data, we have developed a model, right? So there may be other data are here, right? So if we ask to produce what output for the other data using this one, which we have obtained using a small set, this will be a total failure compared to this one, right? So this we call it as overfitting. So instead of these 10 data, if we choose another 10 data, right? And if you develop a model, if it is a good one, the function we are obtaining, okay, there should not be much change, right? So this is the case of, right, overfitting, and this is the case of underfitting. That is, this model does not work not only on the given data points, its performance is poor not only on the given data, but also on the data points which it has not seen. So this is an underfitted model. This we can consider as an underfitted model, and this we consider as an overfitting model. And this is the one, right, which is approximately equal to, right, the given, the true one. So while we are developing a model, we have to make sure that underfitting is not happening, overfitting is not happening. So if you develop a model and if it is right, producing correct answers for the data which we have selected for training, right, we cannot say that we have developed a very good model, right? It may suffer from overfitting, so we have to make sure that our model doesn't suffer from overfitting as well as underfitting. So this is one of the challenges that is involved in the data modeling. Okay, right? So the next slide is types of learning. Can you see?
Yes, ma'am.
Okay. So we have seen that, right? The machine learning is all about, right, extracting information from the data, and there are some challenges involved in. Now, it is all about the data, and we have to extract information from the data. And how we are giving the data to the system, right? Depending upon that, right, these techniques are divided into different divisions. And I have given some few divisions here. Okay. First case is, right, supervised learning. Supervised learning is the one example, right, which we have seen earlier, right? For example, this 3 corresponding, this is expert and this is corresponding Y part, right? 4, 12. So expert corresponding Y part, 5, 50. Expert corresponding. If the data has X part and there is a Y part, right? If you're providing the data in that way, right? We call it as a supervised learning. This Y act as the supervisor, which says something about the data, right? For example, right, if you want to teach a child the right numbers, natural numbers, right? For example, I write 1, 2, and say this is Luke, this is 1, this is 2, this is 3. I write it on the board, right? So the next day, even if I write the one in a very different way, still the child may be able to understand, right? This is 1, right? The child has the ability to even some, we cannot write the letter in the same way each and every time. There may be a little distortions in when we write it. So even then, the child may be able to understand, right, the letters, right? So, and there is a supervisor, there is a teacher who's telling to the child, look, this is letter A, look, this is letter 1, this is letter 2, right? In the same way, here, why act as the supervisor? So if the supervisor is there to give information, to guide the expert, the data is providing in that way, we call it as the supervised learnings, right? Now, next case is unsupervised learning. For unsupervised learning, this Y part won't be there. Okay, only X part. Okay, that is 3, 4, 5. Only X part, X1, X2, right? X3, right? So it's okay. And using this, the algorithm has to do some tasks. For example, divide that into different groups, right? Just as we have seen here, right? So this is an example of an unsupervised learning. Only X part is there, no Y part is there, right? For example, if I give for example, a set of fruits to a group of fruits to a child, right? For example, apple, oranges, right, lemon and grapes, etc. Even though that child doesn't know anything about that fruit, right? The child may be able to divide it into different groups, maybe by its shape, maybe by its color. Like the child may succeed to divide it into different groups, although that child doesn't know anything about that fruits. Using its senses, right? It may be able to divide it into different groups. In the same way, the algorithm has to divide the data into different groups. So we have to, if we specify, we need 3 groups. The algorithm has to understand, right? The characteristics of the data. Using that information, it has to divide it into 3 different groups. If that is happening, if you're providing the data in that way, this comes the unsupervised learning, right? Next comes the reinforcement learning, right? For example, right, if you want to teach a dog, right, how to give shake hand, right? So one way is, right, we give some, right, rewards to the dog, right? That is, if he say shake hand, and if the dog is doing it in the right way, we may give a piece of biscuit. So that is the attractive point there. So to get more biscuits, or to get more rewards, right? The dog will understand that, right? To get to the biscuits, what it has to do. From that information, right, to increase the number of rewards, right, will do the task. This is how we teach a dog to do certain tasks, right? Using the same way, right? Can we adopt the same technique in developing algorithms, right? That is, the algorithm has to do certain tasks so that to increase the positive rewards, right? This is a kind of supervised learning, but the algorithm has to learn. There won't be any supervisor, like there won't be any Wi-Fi. From its experience, it is understanding what actions it has to take, right? Another example is, right, when a child first sees the fire, it has a tendency to touch it, right? But when it touches the fire, it will understand that it will get burned. From that experience, the child comes to know that fire is not something to play with. So when the next time when the child sees the fire, it won't go anywhere near to that. So it is not anybody is telling to the child that the fire is not something to play with. It is from its own experience. It has understood that, right? That fire is not something to play with. So that child got a negative reward there. Okay. In the same way, by giving positive rewards and negative rewards, we are, right, we are teaching an algorithm to take some decisions. Okay. So algorithm which has been developed using those type of techniques, that will come under reinforcement learning. Okay, right? Uh, so, uh, Next is the semi-supervised learning, right?
Ma'am,
Yeah.
can you have little bit louder, ma'am? Or
Oh,
uh, Sometimes it will be shaky and low.
Okay. Is it now clear?
Participants, the voice is clear now.
Yes, sir. Yes, ma'am. Yeah.
Okay.
Okay.
Yeah, ma'am.
It's okay. So next is the semi-supervised learning. Okay. Right? Clear, right?
Yes, ma'am.
Yes,
Proceed.
ma'am. Yes, ma'am. Yes.
Semi-supervised learning means, okay, we have seen supervised learning, unsupervised learning. Okay. So semi-supervised learning means in that data, right? It supervised means y part should be, that output should be there. Unsupervised means y part should not be there. So if we combine both together, right? That is a set of data. If you look all the data, not all the data will have the white part. Some won't have the white part. Some will have the white part. The data looks like that. We cannot call that as completely supervised learning because some data's white part is not there. We cannot call it as a completely unsupervised, but because for some data's white part is there. So what we can call it is a semi-supervised. That is a data for semi-supervised learning. Okay. Right. Next is the active learning. Okay. So active learning is also a kind of supervised learning, but it is a little bit different. Okay. Supervised learning means there will be X part and corresponding Y part is there or output part is there. So we call that output as another name is we can labels. Okay. Okay. Um, so sometimes, right, generating this Y part is very expensive. Okay. For each and every data, generating this, right, this output is very expensive. For example, if I have millions of web documents and I want to develop a algorithm which can classify that web documents into different groups, such as the documents related with sports, documents related with entertainment, documents related with politics, right? Let these are the three divisions. I want to develop write an algorithm which can given a document, it has to say whether in which category that document belongs. Okay, right? But I have millions of web document system. So to develop that such a right model, first we need to have a training data, and we should need to get the Y part also or the corresponding right output. That is for that someone has to gone through the documents and it has to say that whether it belongs to the politics category or sports category or entertainment category. For example, we put y is equal to 1 if it is a politics category, y is equals to 2 if it is a sports category, and y is equals to 3 if it belongs to the entertainment category. So we have 1 million documents. Okay. So we hired a set of group of persons, and that persons has to go through each of these documents, and then it has to mark whether it is y is equal to 1 or y is equals to 2 or y is equals to 3. In that way, we will generate all these data. But this is a very expensive, right? It's very expensive task, right? Hiring a group of persons to go through these the documents, right? It involves a lot of time. It is expensive in terms of time, money, etc. So to avoid that, right? So to make it to be most efficient, what we do is we will we will select a few of these documents, and only for that we will generate this label part, and we will develop a model using this few data, and how that how the performance is going. Then again, depending upon the models performance, and using that guidance, we will again select a few more data using the what is going on with this data. We will add few more data to here, and for that we will right, we will generate these y parts for that few more data, and we will add that to this one. So this process will go until we get the more or less a good model. So in that way, we avoid labeling the all the millions data. Okay, but step by step we added this data, right? In that way, we have right. We have made the entire post process more cost effective. So there is it is not entirely a supervised learning because right we are in between that we are adding one more process is there, that is we are not generating the output for each and every data to generate the training data, but we will first pick a small set and then we will generate the label, and then using that we will find what is the relation between x and y, and then how is it going, then we'll again select a few data for label generation, and then we don't go. So in that, if we go through that process, right, we would be able to get a good model using right a few data sets. Then right, this will avoid labeling all the 1 million data. So if you're introducing that right step also, then that technique is called as the right active learning, right? Then the next one is the transfer learning. Is my voice audible now?
Yes,
Yes,
ma'am.
madam.
Okay. Next is the transfer learning, right? So transfer learning is right. If you know, if you look into ourselves, right? If you know one language, it may be easy to learn another language, right? If you know, for example, Hindi, it may be easy to learn Urdu. Or if we know one programming language, for example, C++, it may be easy to learn some other languages, for example, Java, right? In the same way, right? We have developed a model for some tasks. For example, I have developed a model for right to detect cancer. Okay. So another now I'm given another task. Okay. Right. This task is to to develop a model that could that can identify right rheumatoid arthritis, for example. Okay. So can I use this same model here? Right. But instead of starting from the scratch, right, can I use the model what I have developed for another purpose by making small modifications instead of starting from the very scratch? Can I use already we have developed a model instead of throwing it away for each and every task? We are going all through the entire process. Already we have spent a lot of money and time for developing one model. So right, we use that model for another task, but making some small modification, right? So if we are going right developing a model in that way, that is we have you're using already developed model, and then we going to make some modifications in that. If our technique is going in that way, we call it as a transfer learning. Okay, right? Okay. Okay. Next comes the right. We are going starting into. Can you see the slide?
Part Participants, mute your mic, otherwise noise will come. Yeah, please
Can
mute
you
your
see?
mic. And yeah,
Can you see the heading? Supervised learning.
Yes, madam.
Okay.
Yes, ma'am.
Now, all right. Okay. So we can see now different types of learning, right? Supervised learning, unsupervised learning, reinforcement learning, active learning, transfer learning. Right? So now we will look into more into the supervised learning. Okay. So this is the data. Okay, as I said that, right? This is the input and this is the corresponding Y. Okay, right? And right, so this is xi and this is corresponding y. So if the data is in this form, we call it as the supervised data. Okay, and there are capital and data sets are there. Okay, capital N. So the cardinality, the number of elements in the set is capital N. Okay, right, and this may be a vector. Okay, vector. Vector of length is small n. Small n is the length of this data point. Okay. That is what I said. Then xi is in Rn, r is to n. Okay. This n is called the number of attributes. Okay. Number of attributes of feature. Okay. Number of attributes or another name is features. Okay. Okay. Right. So this is the setup. For example, if I want to model a heart disease data, what we do is, right, we will approach a cardiologist maybe, and as per that person's advice, we will collect these two symptoms from each person. For that, we have collected 100 subjects under study. For these subjects, there will be some normal one which doesn't suffer from these type of diseases, and there may be subjects which is suffering from heart disease. And from each person, we will collect two symptoms. One is cholesterol level and fasting blood sugar. So this is the right experimental setting. And there are number of data is 100. And why small n is equals to 2? Because from each subject, we have collected two attributes or two features. Okay. So, right, number of attributes is 2 and the number of subjects under study is 100. Okay. So, in general, if I take a data point, right, we'll write it as xi1 means ith data's first attribute, ith data's second attribute, ith data's nth attribute, right? For example, here it is for our previous example, this one will correspond to cholesterol level. What is that? And the other one will be cholesterol to blood sugar. Only two attributes will be there. Okay, this is how it looks like. Usually we will write the right vector in the column format. Okay, so that is the standard way. So if I want to write it in a row format, I'll take the transpose of this one. So this is the notation. Okay, right. Okay. So now, what is the right? What is the objective? Right. The objective means we will be given a training data. Right. That is, as we have seen in the first example. Right. You will be given some training data like this. Right. 412. So this is called the right training data, which we use to extract the information. From that, after extracting the information, we will check whether we have succeeded in finding the right, in extracting the information. So, okay. So using this one, we will try to find the answer for this, right? And so, okay, so there will be some testing data to check the performance of the model. And if the model succeeds in the testing data, right, this testing data, why we are using, we want to check it whether it suffers from overfitting, whether it suffers from underfitting, everything we have to check it, right? Whether the algorithm we have selected is good enough for extracting, everything we will check. For that, we will use a separate set of data to check its performance. After all these processes done, when we have satisfied this, we can say that we have, right, we have finished our model development. So it is generalization capacity means, right, the model should give the should work well on the data which we have not used for developing the model. So this is the one, using this data we have developed the model. So that we calling it as the training data, right? Generalization capacity means after the training is over, if it succeeded to find correct answers, not for the one which we have used, but for the one which, right, so it should show good performance, not only for the one which we have used for this one, okay, more or less good performance here, but also it should show, right, it has to show good performance on the data which we have not used for developing the model, right? So that is more important, right? That is why we have seen that. So just by saying that it is doing well on the training data, it doesn't guarantee that, right, we have developed a good model, as I have described before, that overfitting. Okay. So we have to make sure that it works well on the data which we have not used for developing the model. Okay, right? Okay,
Yes, ma'am.
okay. Now, can you see the next slide? Supervised learning, two types.
ma'am.
Okay, right? Is it visible?
Yes, ma'am.
Okay. Now, okay. So supervised learning means X part is there, Y part is okay. On the basis of the Y part, okay, we divide the supervised learning into two. One is classification and the other is regression. Okay. How do we differentiate that? Okay. Right. So if the X part will be there, Y part will be there. Okay. So if the Y part takes only discrete values, or if we can countable the number of values Y takes, we call it as a classification problem. For example, right? This I want to study arthritis data. For that, right, I have collected the electromyographic patterns from the leg muscles. Okay, these are the names of two leg muscles. So, okay. So I have taken this, right? Okay, so we have taken the, can you see it, right? So I have taken the right electromyographic patterns from two leg muscles, right? And there are right 5 data are there, right? From each data, right? We have we have collected the EMG patterns. So, okay. So the number of attributes here is 2, right? And the cardinality of the set is 5. Y number of attributes is 2. Each data is of vector of length 2, right? And if you look at the Y part, right? Y takes only either 1 or 0. That is what we call it as countable. We can count it, right? Or it takes only discrete number of values. If this is the case, we call it as a classification problem. Okay, right? So that is how we are differentiating, looking at the Y part. Okay, right? So in this case, Y takes only 2 different values, either 1 or 0. So in that case, we call it as a two-class classification problem, or another word is binary binary class classification problem. In other case, if Y takes 3 different values, for example, Y takes either 1 or 0 minus 1, we call it as a not 2-class. Now, Y takes 3 different values. So we call it as a multi-class, or for this case, it is 3-class classification problem. Now, the number of different values Y take is greater than 2. So we call it as a multi-class classification problem. So this is how we will differentiate between right classification and regression. So then what is regression means then? Regression means, right, the values Y takes is uncountable. Okay, because for example, Y can take any values between right closed interval 0, 1, right? In that case, we cannot count it. It is uncountable. So we call it as a case of regression problem. Okay, so let us look more into that. So the next slide is can you see it? Binary classification problem.
Yes, ma'am.
So, okay,
Yes,
if
ma'am.
it is a 2-class classification problem, 2-class means Y takes either 1, right? Y takes either 1, right, or 0, right? Right? We call one group as positive group and the other group as the negative group. Usually the positive group is one which we are interested to know more about, which we are interested to study. Here it is the arthritis data. So we call the group for which Y is equal to 1 as the positive class and the other as the negative class. This is the common usual terminology. For example, if we want to study corona, those who are having corona, we call it as the positive class and the other we call it as the negative class. This is the case of 2-class classification problem. Okay. Now that is about the classification. Now we'll look at an example of regression. Okay. Here also 5 data are there and 2 features, 2 attributes. From each data, we have noted what is the angular position and velocity. So here small n is equals to 2. The number of attributes is 2. And if you look at the y values here it is not same as this one, right? Here it can take any real number or maybe between 0 and something which we cannot count it. It is uncountable. Okay. If the xy is looking like that, we call it as a regression problem. After extracting this information from that, when a new data, we will give only the angular position and velocity. It has to give me what is the angular acceleration. So this is the objective. But here, the y part we is no longer we can, right? We can count it, right? It is uncountable. If that is the case, right? We call it as the regression problem. Okay. Okay, right?
Yes,
Okay.
ma'am.
Okay. Now we will look. This is the right. This is how we will right differentiate the supervised learning. Now we go on to the next one. Okay, what is the? We have seen there's some data difference in as far as the classification regression is concerned, and we can differentiate that classification of regression by looking at the y part. If the number of values y take is finite or countable, we call it as a classification. Otherwise, we call it as a regression. Now we look at a case of classification, okay, right? And this is a two-class problem. Two-class problem means this output y takes 2 different values. Okay, 2 different values. Okay, only 2 different values. And how this figure is plotted. Okay, I have introduced what is attributes, right? From each x, right? It has attributes will be there. So let small n is equals to 2. Small n is equals to 2 means
I think ma'am has lost the connection. Please hold. Yeah, please hold, participants. Yeah, maybe ma'am will rejoin.
Okay, sir.
Yeah, maybe ma'am using without headset. That's maybe the reason with voice. I will make a call to ma'am. I will get back to you. Yeah, please fill the attendance sheet. I'll just put in chat box. Hello, ma'am.
I got a message that someone removed from the meeting in between.
No, not like that, ma'am.
Yeah.
Okay. You can continue, ma'am. You are entering in the same mail ID, ma'am. What I shared.
Yeah.
Okay. Okay, ma'am. Let's continue.
It's okay. So you can see it, right?
Yes, ma'am. Yes, ma'am.
Okay. So, this is one, right? So we have introduced what is supervised learning. Now next we'll go on to, right? You can see the slide, right?
Yes, ma'am.
Yes, ma'am.
Hyperplane
Okay.
classification. Yeah.
Good. Yeah. So how we are plotting this point is, right? In one axis, we plot the one attribute, right? For example, if we are taking this data, soleus and gatronimus. So, right, I'll write soleus here and gatronimus here. And I'll write, plot all these data points, right? And as you can see that this, right, this line, right, divides this data into two groups. And so what is classification means, right? This line here, we call it as the decision boundary. Okay, that is the term we call it as decision boundary. So if we succeeded to find the, right, this equation of this line, right, right, then what we do is, given a new point, we can look that whether it lies on this side or this side. Okay, this side, if we call it as the arthritis group, and this side is call it as the normal group. So if I succeeded to find the equation of this line using the given points, right, given any new data point, I would say whether it lies on this side or this side. So this is how the classification, we have to find a decision boundary. Okay, so that is about the one picture, right? Now we'll go on to the next one, right? Next picture, right? If I go on to the next picture, what will happen, right? Here, not only one line, right? All of these, right? Four lines can divide the data into two different groups as per the, for the given data. For the given data, this four lines, right, can divide that exactly divided into two different groups. So, any of these four lines serves a purpose. Is that right? Okay. Okay. Let us look more into this. So if I choose this as the decision boundary, one person has chosen this as the decision boundary, and the another person chose, yeah, this as the decision boundary. Okay. Because both of this give 100% accuracy on the given data. Okay. Now what will happen for a new data? Right, I take the new data comes. Okay, actually the new data is here. Okay, this new data is here. Okay. Now if I show it to the line number 1, right, it will say that it is a normal subject because it is lying on this side. Okay. Now if I show it to the line number 2, it will say that it is an arthritis person because it is lying on this side. Okay, right, it is lying on this side. Right. So for a new data, the prediction differs. Although for the given data, for all these lines give the same answer. Okay, so this is what is these are the challenges here. So you have to find the best one, the optimal one. Although, right, we always we see only a sample of the population, and using the sample only we have to take a decision. Okay, so you have to be very cautious. As you can see that all these four ones will serve our purpose, but we cannot say that we cannot randomly choose one. You have to choose the best one, because as you can see that the predictions will change when for a test data. As I've seen that if I take a point here, as for the first line, it will say that it belongs to the group of blue because it is lying on the other side. As for the second one, it belongs to the red group because it is belonging on this side. Okay, so these are some challenges. So actually, what is in classification? You have to find such a decision boundary, and we put a threshold. If it is on one side, we put it as in one group, and it's on the other side, we put it in the another group. Okay, so so we have seen here a line. Now, and here there are two attributes of the data because X is a vector of length 2. Now I'm going to what will happen when X is of length 3. For that, what did you do? On one axis, we plot one attribute. On another axis, we plot another attribute. And in another axis, we plot another attribute. And now this is no longer a line, but it will become a plane. Okay, it will become a plane. Right. So we have seen line, we have seen plane. Now, if I have 4 attributes, what will you do? That means it will be line, plane, then comes hyperplanes. So hyperplane is a general name. Hyperplanes, we call it as a line. When it comes to this coordinate, we call it as plane when it comes to the this coordinate, or general name is hyperplane. Okay. Now, decision boundaries, is it always a hyperplane? That is something like this, plane, line, or generalization of that. But 2 attributes, 3 attributes, more than 3 attributes, and if the its structures looks like this, we call it as a hyperplane. Whether always the decision boundary is a hyperplane? No. Answer is no. Decision plane may be a hyperplane or not a hyperplane. For example, look at this data. Okay, this belongs to one group and this belongs to the another group. I cannot separate it by, I cannot never find a line such that right, these two belongs to one side and these two belongs to the other side. For that, I need a little more complicated domain decision boundary. Okay. I need a, so that is no longer a hyperplane. So decision boundaries, right? Decision boundaries can be either be hyperplane or not a hyperplane. Okay, not a hyperplane. So we call it as, usually the name is, it's a nonlinear function. So for our data, if you think that as a hyperplane, we call algorithms as you have to use a linear algorithm. And if you think decision boundary is not a hyperplane, we will go for non-linear algorithms. Okay. Or we call it as the data is no longer separable. If you can find a hyperplane for separating the data, we call it as a separable data. Otherwise, we call it as a non-separable data. So that is the case of classification. We have to find a hyperplane or not a hyperplane, but it divides into different groups. So that is the case of classification. Now we'll go on to regression. So in the regression, y part is no longer. You can hear me, right?
Yes, ma'am. It's perfect. No issues.
And right, it is no longer right countable. Okay. So what we do that? Here, regression. Okay. You can see x coordinate, y coordinate. Here, what we do, right? We will plot the attribute number 1. I'm calling it as A1. Okay, attribute number 1, which I'm calling it as A1. And here, what we're plotting is output y part, not like the classification. Okay, the classification, we are not plotting any output. Okay, and this data, that is x1, corresponding y1 is given. Okay, and this is the given data. And we are finding a line passing through this point, through x1 and corresponding y1. So if we've succeeded to find the equation of the line given any x, you can be able to find the corresponding one. Okay. So this is the one. This is the relationship, right? Then if we plot it, it looks like a line. Okay, so in the one axis, it is one attribute. It is not like classification. In the other, we plot the output. Now comes, if I wanted to have two attributes, I'll plot one attribute which I'm calling it as A1 and the other attribute A2 and the Y in the other column. And now it becomes a plane. Now what will have so there are only two attributes of the data, and in the other one axis, we are plotting the Y. Okay. So if I had 3 or 4 or 5 attributes, what do you do? Right, this we are extending. Okay, that is called the hyperplane. Okay, so in general, plane, line, plane, or hyperplanes. So, okay, so and will always the function that approximates, that passes through the data is belongs to this category, that is line, plane, or hyperplane. No, it can be not a hyperplane. This is not a hyperplane. So if that is the case, if we succeed, if you have to find an equation, then given any point, this is corresponding x and this is y. Okay, and in regression, we had to find a function which approximates the given data. So given any x, y, but this is no longer a hyperplane. So we have to use non-linear algorithms, right, to find this one. So regression and classification. So one question, the decision boundary is a line, right? How many attributes data has? As you can see that, right? For this one, 2 attributes, right? And now the next question is, right? If for regression, if the data is a line, how many attributes? Actually, that it is only one attribute, because in the other axis we are plotting the output only. That is right, and we are finding the one which passes through the given data points. Okay, right? So this is about the regression and classification, right? Depending upon the y. Okay, for this case it is not countable, right? Not countable. Okay, this case it is right countable, right? In this case, we are finding a decision boundary, as we get that separation. Right? This we find a function which passes through the given data. Okay. So that is about the regression and classification. Okay. So as we have seen that if you are finding for both classification and regression, if you are finding a hyperplane, right? Hyperplane, it's called nonlinear setup. Here, not a hyperplane. Okay. So that is about the linear and non-linear algorithms. Right. Now that is about the supervised learning. Now we'll come to unsupervised learning. Can you see the slide? Right?
Yes, ma'am.
Yes, ma'am.
It's okay. So that means no y part won't be there. Okay. Y part won't be there. Only x part is there. Right? So given some data like that x may be a vector and the algorithm has to divide it into different groups. Just as I said that a child dividing the fruits into different groups by looking at its color or smell or shape or something according as per the senses, right? Right. If to a very small baby, it cannot do it. Okay. But for 4 or 5 years, it may be able to do it. So when the maturity grows, right? In the same way, the algorithm should be mature enough, or we have to make it to be mature enough so that it can understand the underlying properties and it can divide the data into the groups which we have asked, just like a baby child dividing the fruits into different groups. So that comes the unsupervised learning. Okay. It has a number of applications, right? For example, we have a group we have collected a data from right blood cells. Okay. For example, the study of telomeres and all, we need it. Okay, to detect whether the cancer is there. We collect the data from the blood cells. So no Y part will be there. Okay. So different blood cells, we will collect the data using some devices, and then the collections, the algorithm has to divide it into different groups. This data come from this cells, this data come from this cells. Okay, it has to divide that data, right? For example, if this is has right two attributes, sitting dividing into two different groups, or as three attributes, it has to divide into different groups. That is what it is about the right unsupervised learning. Now, next is the reinforcement learning, right? I want to teach a robot, right, to walk around a rectangle yard. Okay, so what we do is we divide that rectangle yard into different states. Okay, different states, and in each state, what action it has to take. Okay, what some actions will be there, and somewhat action in each state it has to take. And how we teach it by giving some. When it takes the right action, we will give some positive reward, right? So the robot will understand that its aim will be to increase the rewards. For that, what it will take those actions that will lead to the reward sum will be for which set of actions the reward sum is higher, right? That will it will select those actions. So in the same way, how we teach a dog to give shake hand, right? We give some increments to the dog when it says the right actions, right? To increase the increments, right? Always it is like that. To boost people, we give some positive increments, right? To get those rewards, right? Then if it to get then they have a tendency to work harder, right, to get those rewards. Same, right, technique is used in the reinforcement learning. Okay, right. So that is about supervised, unsupervised, and reinforcement learning, right? Now, there are data itself divided into two. Some data we call it as an IID. IID means independent and identically distributed data. Some we call it as the sequential data. Okay, right? That is, for example, the data we have seen here, right? This one. This is IID means, right? There won't be any dependency between X1, X2, and all these will be independent. X1, X2, X3, X4. The occurrence of this has no influence on this one. Okay. So they are independent. Okay. And then another word is they all follows the same probability distribution. Maybe you are aware of, right? For example, binomial, right? Poisson, normal, all will have the same distribution, all follows the same distribution, right? These attributes may be dependent or independent. That doesn't take into account only the data. Okay, X1 is independent. All these will be, there is no dependencies between these data, X1, X2, right? The occurrence of this, right, does have no influence on this one. Okay, so these are called the right. For example, as you can see that data number one, when we collect the angular position velocities, right, the objects from different objects, there won't be any dependency between these data. If that is happening, we call it as a IID data. The name is it is independent and identically distributed random variables. Usually for the normal algorithms, it is like that, right? There won't be any dependency between X1, X2, X3, X4. There may be dependency between the attributes, that's fine, okay? But there should not be any, right? For example, if you are collecting, if you want to study the corona patients, we have collecting data from 100 subjects, right? There won't be any collecting data from one person has no influence on the other. We can independently we can collect the data, right? So in that case, we are calling it as an IID. So for IID data, there are set of algorithms that deals with IID data. Then comes the IID data means all of this will have the same probability distribution. All are mutually independent. The attributes, so if you look at the attributes, they may be dependent or independent. That doesn't take into account, but each of this one has no dependence, right? So if that is called the independent and identically distributed random variables. Then there are not all the data are follows IID. Okay. Then there are sequential data. Okay. What is sequential data? So algorithms which can be applied on IID data, those algorithms we cannot apply on sequential data. That is different. Okay, let us take an example of a sequential data. Can you see the slide?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, sequential slide. Next is the so the task is auto completion task. Auto completion task means when I type D, it has to give me some choices. From that I type E. From the you have seen that, right? That is the auto completion task, as you have seen that, right? In the mobile, and when we type some letters, we will give some choices. So that is the task. So, right, this is data number one, sequence. We call it as a sequence number one. This is sequence number two, sequence number three, sequence number four. Okay. Now, for example, this we cannot treat as we have dealing with this corona patients data where there is no dependency. In that way, we cannot deal these type of data because, right, if you take this one, right, uh, we divide these into small subsequences. For example, S1, this is the first one, D, right? Our task is to develop an auto completion task. So what we do is we will divide as into this one. I am calling this is sequence number one, and I'm calling the D as X11, E as X12, and the X13, X14. So, and what is that? When I type D, it has to the prediction corresponding to this is E. The prediction corresponding to the next one is when I type the next one E, it has to say what is the next letter Y2 or Y3, and then Y4 stop it. Okay. So, right, there is a dependency between D and E, E and D, E and P. Okay. Right. So if the data is like that, there is no dependency between S1 and S2 learning. They are independent, but if you look at this each sequence, we can divide that into subsequence as per our task, right? And there is we cannot deal these data in the same way as we have the data which we have seen before, or as post tagging. Post tagging means, right, we have to say whether each word is a verb, adverb, or noun. That, right? So that is the post tagging, right? So you have given the data here. We are here. This is sequence number one, and this is sequence number two, and our task is to write post tagging, right? So this is S1 and this is S2. Here we divide it into subsequences. Here the first one, each subsequence consists of only one alphabet. Here it is different. Here now each subsequence is a word. Why? For the first one, first subsequence is Y, second subsequence is not, third subsequence is tell, and fourth subsequence is X1. And actually, right, that no, which is noun, which is verb, it depends. There is it depends upon, right? Sometimes some word will serve as noun, or it may not be noun always, right? Depending upon the context, it may change, right? So there is a if you take any sequence, and that subsequence will have a relationship, we have to take into account that relationship also. Okay. For example, if you take Y, the prediction, it should be adverb. It has to, for each subsequence, it has to give a prediction, not a Y verb. Tell, it has to. So this is how that division goes. Okay. And there is a relationship between these subsequences. Okay. If I take the next sequence, there is no relationship between S1 and S2. But if I take, this is a sequence data. Okay, S2. This is a data which and we divide that into different subsequences, and we have to take into account the the dependency between the that subsequences. So this we have to we cannot deal these data just like the data which we have seen before, right? Here, and also in these two tasks, for each subsequence means right, this is a sequence and I'm dividing it into different this is subsequence one, this is subsequence two, this is subsequence three, subsequence four, for the for the first sequence S1, right? And I need to get a prediction for each this subsequence. What is Y, whether it is a verb or not one. But for some cases, right, we not doesn't we don't need the prediction at each and every point. For example, we want to make a sentiment classification. Sentiment means a comment is there. After reading the entire comment, it has to say whether it is a positive comment or a negative comment. There also, right, we will take that sequence and we divide it into small subsequences, and there will be a relationship between the subsequence, but we have to say the prediction at the end only. There is a positive comment or a negative comment. Here, for each subsequence, you have to say the prediction, right, for the post tagging and auto completion task. So these are some examples of sequential data, and the other is the IID. Okay, right? Okay.
Yes, ma'am.
Yes,
Okay, so we have seen that, right, IID, right, and sequence data. We will see a very few, right, there's some basic machine learning algorithms, right? But actually, if you look at the field of machine learning, right, it involves a lot of mathematics and right statistics. Okay, from the mathematics, it will make sense of linear algebra, optimization, multivariate graph theory. All these will be using in right to develop the algorithms, right, and probability and statistics. Now, to implement it, you should have a very good knowledge in computer science, right? To implement efficient implementation. So the computer knowledge, right, comes actually in the right implementation only. But it's right. The formulation is entirely algorithm formulation. Even a person who doesn't have any right computer science background can study machine learning, right? But should have a good mathematical background. Now, that is to understand the theory. Okay. Then comes the implementation. Of course, we should have a very good hold in, right? Programming, implement this. Okay, so these together, this is a field, it's an interdisciplinary field. Okay. To this algorithm for a lot of mathematical and probability and statistics concepts entirely it is using these concepts to develop the algorithms. When it comes for the implementation, you should have a good computer science right knowledge, right? So that is the field of machine learning, and it has applications in almost all walks of our life, right? So with this, I'm introducing a very small, a very easy, a very simple algorithm. And here the data, we are not sequence data, but IID. That is, if I have X1, X2 to X capital N, not as the sequence data, we can take X1, we can take X2, and there is no dependency between this data. Okay, if that the data is like that, I'm introducing a very simple algorithm called KNN. KNN means K nearest neighbor. It is very easy to understand it. Okay. And how it is work, right? And it is usually calling it as a lazy learning algorithm. Why it is calling it as, right? So you will be given a training data. Okay. Using the training data, it has to extract the information, and using the information, it has to predict the testing data, right? So why it is called the KNN means when the training data is given, it doesn't do any work. Okay. Only when the testing data comes, its work start. Usually the algorithm is not like that. Given the data, it will extract the information and then we will apply it on the test data. Here, it is not like that, right? Only when the test data comes, it starts its work, and how it is how it is working. Okay, let us see. So it's a very simple, easy to understand it. Okay, I have a training data. Training data is the one which we have used to right extract the information. So 4 data are there, and Y1, Y2, Y3, Y4. Okay, now apply KNN here. Okay, apply KNN to this data. So new data. I want to predict what is the Y value of this X. Okay, so this is the scenario. And how KNN works is okay. So this we are using for classification problem. Okay, this we are using for the classification problem, taking the case of classification. Okay, and let it is a two-class classification problem. Two-class means y takes two different values. Okay, let y takes either 1 or 0. Okay, right? Two-class classification problem. And how this KNN works means when a new data comes, it will find the distance between each of the training data. Distance, that is, to find the Euclidean distance, right? I'll find so in the same way, it will find the distance between how close each of this data to the given point. That is, I'll find the distance between x1 and x. Then I'll find the distance between x2 and x. Then we'll find the distance between x3 and x. Then we'll find the distance between x4 and x. Okay, for this one. Now, what is K stands for, right? Right. So if it is K is equals to, right, 2, right? Okay, right. That means what we do is find K nearest neighbors. That is K, let us be 3. Okay. K is equals to 3 means it will find 3 points which is closest to x, right? In distance wise, which are the 3 points which is closest to x, right? That is, we first find the distance between all these points, and among that one, we will find that one which is closest to x. So I got x1, x3, and x4 are the one which is closest to x as per the distance wise, right? And then what we do is we will look at the class of this one. Okay. So if this belongs to class 1, and this belongs to 0, and this belongs to 0. So here the majority belongs to the 0 class. So I put x in the 0, x label as 0. So that is how it works, right? Understood, right? What is that? When a new data comes, right, it will find the k nearest neighbors of the, right, unknown data, right? That is, if I put k is equals to 3, it will find 3 data points which are at a minimum distance to the given point, and we will decide the class as per the majority decision. Okay, right? Here K is the hyperparameter. Hyperparameter means those parameters which we have to set before starting the algorithm. There are two types of parameters. One is the hyperparameter and the other is the parameter. Parameter means those values which the algorithm will find for us, and hyperparameters means we have to set the values for running the algorithm. Before starting the algorithm, we have set the values. Here, K is called a hyperparameters because we have to set whether you need K is equals to 3 or K is equals to 4 or K is equals to 5. K is equals to 4 means it will find the 4 data points which is closest to the closest to the new data or the testing point, and then right we will look at the class of that 4 points which is closest to the new point, and as per the what is the majority is saying, right, as per the majority decision, we will assign a class to the new point. Okay, so this is what is the K nearest neighbor, right? Okay, right? Okay. For example, if I have x1, x2 to x10 points are there. So I corresponding y1 will be there, y2 will be there, to y10 will be there. Okay. When a new data comes, and if I put k is equals to 3, what it will do? It will find among all these 10 points, I choose 3 points which is closest to x. Okay, 3 points. For example, let it be x6. Okay, x4, right, and x10 are the one which is closest to x. Okay, among all the 10 points, x6, x4, and x10. Then, right, okay, then what is the majority? If the majority belongs to positive class, we put X in the positive class. If the majority belongs to the negative class, we put it in the negative class as per the two-class classification problem. Same will we can go for the multi-class classification problem also. Okay, so that is how this KNN works, right? So okay, it's a very simple algorithm to understand. Now we will quickly look it into, right, how we can check the
Excuse
this
me,
is the
ma'am.
type of yeah.
Ma'am, on what basis do we set the K value, ma'am?
Okay, that is all we have to decide it, right? That is what hyperparameter that is coming. Okay, we have to choose the best hyperparameter, right? For that, right, we will try with different hyperparameters, and as per the one which is giving us good performance, we will set the K value. Okay. That is what we are going to look at into. Okay, if there is a time. Okay. Okay. Uh,
Okay,
for,
ma'am.
for that, first I will introduce the different performance techniques. Then only we will say how to check the performance, right? That is why this has been introduced. Okay. So the hyperparameter is K. We cannot arbitrarily set it. We have to follow some strategy in setting it. That is on the basis of the performance of the model. So the next question is, how will you find the performance of the models? For that, right, I'm going to introduce something. I'm speaking about the two-class classification problem. Okay. We are concentrating on two-class. Two-class means y takes two different values only. Okay, right? And for this, I'm introducing some terminology called confusion matrix. It's not confused, but the name is confusion matrix. And what is that? For that, there are some terminologies called true positives, false negatives, false positive, true negatives. Okay, these are all we are introducing to find how we can check the performance of the models. And then comes using the performance of the models, we can choose the best hyperparameter. Okay. So I'm going to introduce it, some terminologies. True positive. True positive means, right? So given a data, we will divide some data as training point and some data as testing points, right? But we know the y values of the testing points, but we ask the model to predict the y values of the testing points. Then we will model, right? For example, our testing data, right? Testing data is given as, right? Uh, xt1, right? yt1, xt2, yt2. This is a testing data, xt3, yt3. Okay. So this is the given value, yt1, yt2, yt3 is the given values. Okay. And we develop a model using training data, and we'll ask we'll give only xt, and we will ask the model to predict, and it will predict it will give some values, and then we'll compare that with the given values. This is the given values. Okay, right? Let this be 1, this be 0, and this is 1. Okay. Right, yt1 is equal to 1. Okay. And if the model is predicting, model prediction is 1. Model prediction is 1, the given value is 1. That means the true given value and the model prediction is correct, or else we call it as true positive. The model prediction and the given value is correct. Okay, right? Now, false negative means, right? Uh, we call uh, those one with 1 as the positive class and those one with 0 as the negative class. Okay. If instead of 1, if it is predicting as 0, right? It is predicting as 0. So actual, it is a positive class. Its yt1 is 1, but it predicts as negative. we call it as false negative. It is falsely saying, wrongly saying that it belongs to the negative class. Its prediction is wrong. Actually, it is for positive, but it predicting it belongs to as the negative class. That is what is false negative. Falsely, it is saying it belongs to the negative class. Now, false positive means, right, if YT2 is actually belongs to the right, let YT2, it belongs to the negative class, right, 0. But the model is predicting it as 1. That is, it belongs to the positive class. So what is it is false positive. The model is falsely saying that it belongs to the positive class. Actually, it belongs to the negative class, but the model is saying it belongs to the positive class. So, right, we call it as the false positive. True negative means, for example, YT3, it is 0. It is belongs to the negative class, and the model is also predicting as 0. So it is true negative. Both the given and the prediction is correct. This is true, right? True positive. So, okay. This is false positive. Okay. False positive. That is now we will say false negative means, for example, YT4. False negative means actually it is 1 and the model is predicting it as 0, right? The 0 means, right? Actually, it is a positive, but the model is predicting it as 0. It falsely saying that it belongs to the negative class. So it is, we call it as the false negative. Okay, right? So these are the, so with this is the confusion matrix, right? So actual class, positive, and the class and the prediction is also positive. We call it as it's a true positive. Actually, belonging to the positive class, but the model says it belonging to the negative class, then model is falsely saying it belongs to the negative class. Then comes the false negative. Now, actually, the data belongs to the negative class, but the model is saying it belongs to the positive class. That is it falsely. That is the false positive. Then comes that the data is belonging to the negative class, and the model is saying it is belong to the negative class. We say it as a true negative. So, okay, so that is what is true positive and true negative. Okay, now we for the classification, there are some performance measures which we use. One is the accuracy, right? Accuracy means you know that, right? For example, XT1, XT2, right? XT3, XT4, right? We will ask the model to predict the corresponding prediction. Okay, right? And we have when we compare this with YT1, YT2, YT3, YT4. Okay, so then we will count it how many correctly classified. Okay, divided by the total number of data. If it is out of this 4, if it has correctly classified 2, its accuracy is 2 by 4. Or else it is same as how many it correctly said as positive plus how many it correctly said as negative. That will be that is 2, right? And the total number of data means some it has said as correctly predicted as positive. For some, it is correctly predicted as negative. For some, it is actually belong to the positive class, but it falls actually belong to the negative class, but it says as a positive class. That false positive. False. This is the entire data. We can divide it into the these type of groups. So that is using these terminologies, we can represent accuracy as TP plus TN by true positive plus true negative plus false positive plus false negative. Okay, so that is accuracy. But this accuracy is always a good measure. Accuracy can by saying right accuracy. If you're getting very good accuracy, can we say that the model is performing well? Okay, let us take an example. Okay, right?
Ma'am,
Okay, time
hello.
is there. Time is
Ma'am,
over.
yeah, ma'am. 4 minutes is there. Is there any QA or something? Something is there?
Okay, okay then.
Yeah.
Okay.
Yeah. Is there any questions or queries? We have only 4 minutes there. So participants, please unmute and ask and interact with ma'am. A few questions are in the chat box regarding, I mean, some few questions in ML for scheduling in 5G or use when to use the deep learning methods. These are the questions in chat box, ma'am.
Okay, so deep learning means, right? I have introduced some attributes, right? For the data I have given you, there are some attributes are there. But for some type of data, they're called the engineered features, right? I have shown you, right? The Soleus, Catronius, like we have, right? We have collected those data, right? So they are called the engineered features. But for some data, right? We there won't we won't explicitly we don't give the features. The algorithm itself has to find the features, right? For example, I am given some images, right? The cat, dog, and dog. So it is not representing the data which we have seen like that, the attributes, but only the cat images, right? That RGB metrics we will see. We will feed that data to the algorithm. Then from that data, the algorithm itself has to find the important features, right? If that process is going on, right? We use deep learning, but that is not the actual definition of deep learning. But I'm saying it in a way that these are the applications where the deep learning is used, but that is not the actual definition. But the applications where we usually the deep learning is used in these areas, right? So okay, right? I-
Ma'am,
Yeah,
right.
please.
ma'am, whether deep learning and machine learning algorithms can be interchangeable?
I don't know. That is interchangeable means usually people call it as machine. Actually, deep learning is only a domain of machine learning. Okay, multi-layer perceptron, right? In multi-layer perceptron is an example of a deep learning algorithm only, right? But there also we will give the data as attributes, right? Attributes only. But in the case of another deep learning convolution, CNN, we don't give the data, we give only the images and the algorithm has to find it out. Actually, right, some deep learning means what is the actual meaning is, right? It is the model form is a composite function. Composite function means, right? If I'm writing function, we can write it as f of x, right? And composite means f of g of x. That means first I will apply g, then I will apply f. So two functions are coming. So that is what is deep means, right? So there are two functions. If I adding one more function f1, f2, f3 of x, three functions are coming. So the number of functions is getting increased. That is what is actually meant by deep. The number of the functions involved in that composition. With that only the name is deep. And right, there is no deep learning is only a domain of people call it as machine learning and deep learning. No, deep learning is only a part of machine learning, and it's a machine learning algorithms, and it's an example is a multi-layer perceptron. Multi-layer perceptron is also the data is given same as we have seen in KNN, but in some cases other, for example, right, if I want to for post tagging and all, we will give only the sentence. Then from the sentence, the algorithm has to find out the features. Then why the name deep learning has coming is, as I said that it will be a composite functions, right? F1, F2, F3, F4 to Fn of H. As there are n functions are coming, we call it as the length of depth n, right? So that is what it is actually. It is the deep learning, right? Okay.
Thank you, ma'am. Thank you.
Okay.
Ma'am, may I share your mail ID in the chat box?
Yeah.
Yeah.
Okay.
Okay, if there is any question, please ask. We can take 2 more minutes. There any question? Can discuss with ma'am. Okay, ma'am. Thanks a lot, ma'am. Thanks for your support for this international workshop. Thank you for the thank you participants to attending this session. I think you will get a brief idea about the machine learning basics. That's what I want. That's what we want actually. Yeah, for the proceeding the sections in the coming days also. Thank you.
So
Thank you.
yeah, I would also like to express my gratitude, to all of you. I hope, by this talk you have got some basic concepts about machine learning, right? Now you can build up, right? Now you can read and learn. You get some introductory concepts about this time limit, right? You've got some introductory concepts about machine learning. Yes. Okay. Have a nice day. Wish you the very best. Thank you.
Thank you. Thank you, ma'am. Thanks a lot, ma'am. Thank you.